Today, in this video, let's deal with the mechanism of action of sulfonamides. Before going to deal with the topic, let's go into the introduction part of sulfonamides. Sulfonamides were the first microbial agents effective against the pyogenic bacterial infections. Protonsil red was one of the dyes included by the great scientist named as Domag to treat the experimental streptococcal infection in the mice, and later it was found to be highly effective. And subsequently, with the same dye, he cured an infant who was suffering with the Staphylococcus septicemia. Later, it was found that the role of the protonsil in the body was the protonsil subsequently was broken down into the sulfonilamide, which was the active antibacterial agent. Later, due to the development of the various antibiotics and the highly effective antibiotics, the utility of the sulfonilamides got reduced. And in the present situation, these sulfonamides are not used individually. It is been only treated with the combination therapies. Example, sulfonilamide plus trimethoprim, which is a cotrimoxazole, which is used to treat various infections, and pyrimethamine plus sulfonamide is used as an anti-malarial agent, and it is also used to treat toxoplasmosis. It is a broad spectrum antibiotic which is primarily bacteriostatic against the many gram-positive and gram-negative bacteria. However, these bactericidal concentrations may attain in the urine, so it may lead to crystalluria. This is one of the adverse effects that is being seen in sulfonamides. Now let's deal with the chemistry of the sulfonamides. The sulfonilamide structure is similar to the para-aminobenzoic acid. It is an analog of para-aminobenzoic acid, where the carboxylic acid is present in the para-aminobenzoic acid that is being substituted with the sulfonilamide group that is present in the sulfonamide structure. Coming to the classification of the sulfonamides, they are being classified into four different types. They are the short-acting, long-acting, intermediate-acting, and special purpose sulfonamides. Now let's deal with the mechanism of action of the sulfonamides. Basically, these sulfonamides deal or disrupt the folate metabolism, folic acid metabolism in the bacterial body. So, what is the use of the folic acid? Folic acid is generally used to synthesize the purines and the pyrimidines, which is where these purines and pyrimidines are used to synthesize the DNA. This DNA is used to regulate the cell cycle, regulate the cell functions and the cycle. So let's see how these sulfonamides are going to disrupt the folate metabolism. Basically, coming into the regular cycle, pteridine which combines with the para-aminobenzoic acid, it gives the dihydroteric acid in the presence of dihydroterate synthase. Later, this dihydroteric acid combines with the glutamic acid. It gives a dihydrofolic acid. And this dihydrofolic acid in the presence of dihydrofolate synthase, it gives tetrahydrofolic acid. Later, this turns into the purines and later it synthesizes the DNA. So, the main function of the sulfonamides in this cycle is it combines with the enzyme dihydroterate synthase in the competitive inhibition process. It competes with the para-aminobenzoic acid, which was first said that it is an analog. It is an analog of sulfonamide is an analog of para-aminobenzoic acid. So, with the competitive inhibition mechanism, these sulfonamides goes and binds with the enzyme dihydroterate synthase, which later leads to the formation of altered folic acid. This folic acid, which is synthesized in the altered way, this folic acid will basically disrupt the metabolic activities of the DNA, and it is injurious to the health of the bacteria, and later the bacterial growth is being stopped. So these sulfonamides are basically acting by the competitive inhibition process. So let's see the adverse effects of the sulfonamides. The common adverse effects that are being seen are nausea, gastric pain, and vomiting. Crystalluria is being seen when the bactericidal concentrations are attained in the urine, and hypersensitivity reaction is seen in 5 to 10% of the patients, and hepatitis is a very rare condition, and hemolysis is being seen in the very rare condition, and coronary is a common side effect that is being seen in newborn babies. It is not being seen in the adults and other adult people. So let's see the uses of the sulfonamides. They are rarely used, but they are used in combinations. Now it is not being used in an individual product. So this can be used in the treatment of various infections like chronic UTI, pharyngitis and gum infections. Combination with this trimethoprim, it is used for treating the bacterial infection, and combination with the pyrimethamine is used to treat the malarial and toxoplasmosis, and they are also used to treat the infections on the burnt surfaces. Basically for the burnt surfaces, methadone is being used. It is a derivative product of a sulfonamide. Thank you for watching the video. If you like the video, please do share, subscribe the channel. Thank you.